Hi students, this is Ms. Skokin. Welcome to section 6.6, the remainder and factor theorems. Our objectives: evaluate functions by using synthetic substitution, and synthetic substitution is going to look a lot like synthetic division, and determine whether a binomial is a factor of a polynomial by using synthetic substitution. Our vocabulary: synthetic substitution, depressed polynomial, remainder theorem, and factor theorem. And we are going to read: when you divide a polynomial that we're going to call p of x by the factor x minus r, then the remainder from that division ends up being the same as the value of the function when r is substituted in as p of r. All that's saying is whether we use synthetic substitution or we use direct substitution, we're going to end up with the same value. And let's take a look at an example. So if f of x is equal to 3x to the fourth plus 2x cubed minus 5x squared plus x minus 2, find f of negative 2. I want you to do the direct substitution part first. So what you're going to do is you're going to take that polynomial and you're going to plug in negative 2 for x. When you have finished doing that and you have a value, turn the video back on. Okay, we did the direct substitution. We replaced x with negative 2, and you can see that we ended up with f of negative 2 is equal to 8. What we're going to do now is we're going to use synthetic substitution, and that looks a little bit different. There's something called the remainder theorem, and that's what we saw just above in the box. What we're going to do is set up what looks like a synthetic division, but it's not a synthetic division because we're not trying to divide by a binomial. What we're going to do now is set it up as a synthetic substitution. So where we're starting out with the possible factor of the polynomial x plus 2, we're going to look at that in our x minus r format. So if we look at it as x minus r, then we know r is equal to negative 2. Negative 2 is going to go inside the box, and it's going to represent this binomial possible factor of f of x. So set up the synthetic division and then turn the video back on. Okay, we've got the synthetic substitution set up. We bring down the 3, multiply, we get negative 6, add, we get negative 4, multiply, and keep going until we finish the synthetic substitution. And you can see the result that we ended up with. Oops, that's supposed to be a negative 2 right there. Okay, so the result that we ended up with was 8 for the remainder. There's our constant term. There's our x squared, and our x cubed. Okay, so what the remainder theorem is saying is that this number, the remainder, is 8, and you notice that's what we got for our direct substitution. So according to the remainder theorem, f of negative 2 is equal to 8. We already tried it with direct substitution. We knew that that's what we would get, and you can see now how we got it with the synthetic substitution. Alright, so we have another example here, and if f of x is equal to 5x cubed plus 2x minus 1, find f of negative 3. I want you to fill out both the synthetic substitution side and the direct substitution side, and then turn the video back on when you're finished. However, just very quickly before you get started, remember that you need to check, just like we did in synthetic division, for synthetic substitution you have to check and make sure that there are no missing terms. If there are, you have to fill in the zeros. So turn the video back on when you're ready to check your work. So here again, whether by synthetic substitution and looking at the remainder or by direct substitution, we get the same answer, 140. So that means when we substitute 3 in for x into f of x, we get f of 3 is equal to 140. But what it also means is rather than having to substitute in directly, like we have on the right, we can use synthetic substitution, which we know is a very easy procedure. And that allows us to use the remainder to find what the direct substitution value would be. So let's take a look at the next page now, and we have now the factor theorem. What we had, I'm just going to look at the previous page. This is the remainder theorem right here. This is the remainder theorem, and then on the next page we're looking at the factor theorem. Now what does the factor theorem say? It says when we substitute r into the polynomial p of x and we get p of r is equal to 0, then that means that x minus r is a factor of p of x, or we've been able to determine what one of the factors of the polynomial is, one of the binomial factors of the polynomial. Now we know that polynomials can be hard to factor, and so this is one way that we can factor the polynomial and at least determine one factor of the polynomial, one binomial factor of the polynomial, and then what we have left over, you remember from synthetic substitution or synthetic division, we end up with the depressed polynomial, and it's decreased by 1 degree, which was the degree of the binomial that we divided by, and then we can find the rest of the factors either through the quadratic formula, further factoring, or trying out other factors to see if we get a remainder of 0 again. So by the factor theorem, the binomial x plus 5 is a factor of the polynomial, and that's the polynomial that we have above, x cubed plus 2x squared minus 13x plus 10. So the binomial x plus 5 is a factor of the polynomial if x plus 5 is a 0 of the polynomial function. And to check this, what we're going to do is use synthetic substitution. We know our form is x minus r, and since we have x plus 5, we know that r has to be equal to negative 5. Next, we're going to set up this synthetic substitution, and we're going to determine whether or not we have a factor of the polynomial function, this x plus 5 number. So we're going to put negative 5 in the box. We're going to check our coefficients and make sure that all the degrees are accounted for. Our highest degree monomial in the polynomial is 3. So our coefficients are going to be 1, 2, negative 13, and 10. When we run through the synthetic division, we end up with the depressed polynomial x squared minus 3x plus 2. We have a remainder of 0. Since we have a remainder of 0, then we know that our original binomial x plus 5 is in fact a factor of the polynomial x cubed plus 2x squared minus 13x plus 10. Now, we know that that's a polynomial because we just used this procedure. So what we're going to do in the next box is, since the remainder is 0, we know that we can factor the polynomial. So let's set it up in terms of its factors. The two factors, of course, being x plus 5 and the depressed polynomial that we just came up with. What we're going to do now is we're going to take that depressed polynomial and we're going to factor that. Now, this one happens to be factorable. If it's not factorable, we can always use the quadratic formula to factor it and find the other factors. But in this case, it is factorable. There are two numbers that will multiply to positive 2 and will add to negative 3. They are negative 2 and negative 1. And what that means is that we actually have 3 factors to the polynomial: x plus 5, x minus 2, and x minus 1. And we've shown our 3 factors to the polynomial right at the bottom line. Now, we have another example here, and what we want to do is we want to determine whether x minus 3 is a factor of the polynomial x cubed plus 4x squared minus 15x minus 18. And then we want to find the remaining factors of the polynomial. So what we're going to do is we're going to set up our synthetic division again. If, in fact, we get a remainder of 0, then we know that x minus 3 is going to be a factor of the polynomial. The things you need to watch out for: remember our format is x minus r, and remember to check for any missing degree terms. Once we've got the synthetic division done and we get our depressed polynomial, either factor the depressed polynomial or use the quadratic formula in the box on the right so that we can find other factors of that polynomial. When you're ready to check your answers, turn the video back on. So in this section 6.6, what we've learned how to do is determine whether, based on the remainder theorem, determine what direct substitution would yield if we did direct substitution, but we're going to use synthetic substitution instead. So whatever the remainder is what we would get through direct substitution. Also, we learned the factor theorem that tells us that we can find a factor of a polynomial if we use synthetic division and we end up with a remainder of 0. Then we know it's definitely one of the factors. If it is one of the factors, we can take the depressed polynomial, either factor or use the quadratic formula and factor further so that we can get all of the factors of the polynomial. That is it for section 6.6. It's a short one. Make sure you've got your notes filled out properly, and we'll see you in class.